Believe it or not, a week from today, we're done. So we just have 6.7. I'll do that for a while today, but we'll probably end early. I'll do the rest tomorrow. We'll probably end early. Wednesday, the normal question and answer period. And the test again is on Thursday this time, not Friday. This week the test is on Thursday. Again, I'll try to get you back your exams Friday, but I'm not promising that, but I'll for sure aim for the weekend. But I'll make out the video for you hopefully by Friday so you can grade yourself sort of and use that to study for the final exam. So again, as I'm doing less and less material now, you're hopefully spending half the time learning new stuff, but half the time you're going back over exam 1, exam 2, exam 3, and 4 and 5, and brushing up on what you need for the final exam. Again, for the formula sheets, just take all the previous formula sheets. You're allowed to have them all. And if you want to add stuff to them, you can. Like maybe now you're saying, oh, I wish I put back in something on the third test. You can do that now. You're allowed to put extra stuff. That's certainly okay. All right, and so reminder, final exam is a week from today already. That's Monday the 14th, 8:10 to 10:40. So I'll open the Zoom meeting at 8 o'clock or a little bit after 8. I will email you or send you Canvas announcements again, the final exam. And then you'll just get started and you have 2.5 hours to do it. Okay. And how many questions will there be? Well, I usually give about 10 questions, so fair would be maybe in the neighborhood of 20 questions, something like that, since you have more than double the time. Okay, so plan on roughly 20 questions, fairly evenly spaced between the 6 exams. So let's see, if we have 6 exams, 6 times 3 is 18. So maybe if I give 18 questions, that's good enough. 3 questions from each test. That's sort of what I'm aiming for now. The questions will look just like the previous exams. They're not multiple choice. They're not true, false, or anything like that. They're problems. So I'll just go to every test, right? And so like the first test, I might say, okay, I like that one, and that one. And the second test, I like that one, and that one, and so on. I might change it up a little bit and do that for all the tests, and that'll be the final exam. Okay. So it is sufficient to just study off of the old exams for the final exam. Don't go back and study everything. There's no way you can study everything. So I narrowed it considerably, but just saying study the exams, I mean, that's enough in my opinion. Okay. So that's what's happening. So I did very little of 6, 7. I'll do more today and more tomorrow, and we're on to our last section, and then that's pretty much it for the course. Okay. Does anybody want to ask a quick question now? Let me check the chat. Let's see. Of course, you can ask later. Yeah, I don't see anything in the chat right now. So we'll go ahead and get started. Okay, the quiz. So it's now too late to submit a quiz. X squared over 16 plus y squared over 25 equals 1. So B is 4, the number underneath the X. A is designated as a larger number. A is 5. So this is a 3, 4, 5 situation. A squared equals B squared plus C squared. A squared is 25. B squared is 16. C squared is 9. C is 3. Yes, you probably already caught that 3, 4, and 5 also show up in question 2. I made it that way. Okay, so the foci are always along the major axis. So some of you had the foci going this way. It has to be on the major axis. So the vertices are 0, 5, and 0, negative 5. The foci are 0, 3, and 0, negative 3. The endpoints of the minor axis are negative 4, 0, and 4, 0. They're not given any special name. And it's bulging in the vertical direction because you're going up and down 5, but you're only going 4 left and right. So it's bulging a little bit in the vertical direction. So there we go. Okay, so some of you had it bulging the other way. I do give you partial credit, but it's supposed to be going the other way. Number 2, y squared over 9 minus x squared over 16 equals 1. So y is first as positive, x is negative. So that tells me it's the up and down kind of hyperbola going like that. Okay, so A is 3, B is 4. So for the hyperbola, designations of A and B aren't by the larger, just by whichever is first. So A is 3, B is 4, C is 5. So C squared equals A squared plus B squared. So but that's 9 plus 16, which is still 25. Okay, so here we go. 1, 2, 3 up, 1, 2, 3 down. So my vertices are 0, 3, and 0, negative 3. Foci are 5 up, 5 down, so 0, 5, 0, negative 5. Left and right, I go 4. And I draw myself the box, draw the 2 diagonals, and just curve the hyperbola toward the asymptotes. So this is over 4 up 3, so y equals 3/4 x, and y equals negative 3/4 x. These will always be opposites. So if this is like 2 over 5, this is automatically negative 2 over 5. That's never going to change. Okay, so that's the quiz. And that was our last quiz. Okay, so no more quizzes. Yay, we're done. You get to drop 1 out of every 4 quizzes. Okay, now that would have been ideal if I had 12 quizzes. We're only going to have 11. So guess what I'm going to do for quiz 12? There's a bogus question 12, and you all got 5 points on it. Okay, so how do you like that? So if you vehemently complain about my giving you a free quiz of 5 points, then you can let me know, and I won't give it to you. But okay, I was supposed to give you 12. I only got time for 11. So there's a bogus question quiz 12, and you all got 5 out of 5 of it. Okay, so how's that? All right, so we're supposed to make things a little bit easier for you because we're into COVID, and I guess the restrictions are even worse nowadays, right? So we're supposed to make it a little bit easier. So that's one way of making it a little easier. If there's a 12th quiz, and you all got 5 out of 5 automatically. Okay. All right. Okay. So back to parametric equations, of which I started very little last time. Okay. So you have x is a function of t, y is a function of t. Okay. So if possible, get rid of the t, and so we can figure out what the shape is like. So I did a few last time. We'll do several more today until I feel like I've done enough. All right, so last time I did just 1 and 3. So here's question 5. X equals sine of t, y equals cosine squared of t. All right, now, whenever you have something involving sine and cosine, you want to try to use the identity sine squared plus cosine squared equals 1. Okay, maybe I'll just write that down here again. So sine squared of t plus cosine squared t equals 1. And you've seen that before already, but if you want to put this on your next cheat sheet, you may. That certainly will help. Okay, so anything that has sine and cosine, like 5, 6, 8, 9, try to use the fact that sine squared plus cosine squared equals 1, and you try to force an equation that has that. For secant and tangent, that's a little bit different. Then you want to use a different identity. I'll show you that when we get to number 7. Okay, so here's what you do. X is sine of t. Y is cosine squared of t. Now, before I go on, okay, I labeled it on front here at the get-go. X is sine of t. We already know that sine can only give me stuff between negative 1 and 1. So x has to lie between negative 1 and 1. So that's why I wrote this tiny little thing right here. X is between negative 1 and 1. Okay, we don't need that now, but we'll need that when we start the graph. Okay, y is cosine squared t. Okay, now cosine lies between negative 1 and 1. Cosine squared can no longer be negative. So cosine squared, that means y can only be between 0 and 1, inclusive. Okay, so one more time. Restriction on sine. Okay, if you think back of the unit circle, right? Both sine and cosine can only give you stuff between negative 1 and 1. So that means x is between negative 1 and 1. Cosine is between negative 1 and 1. But now that you square it, you can no longer have a negative. So cosine squared is between 0 and 1. All right, now what do I do after that? I try to force there to be an equation that says sine squared of t plus cosine squared of t equals 1. Or you can have the cosine squared first. Obviously, that's the same thing. So this already says cosine squared. This says sine of t. I'm going to square both sides. X squared equals sine squared t. And what do I want to do that for? Because now I want to get sine squared plus cosine squared, because then I can just replace it with 1. So x squared plus y, x squared plus y is equal to sine squared t plus cosine squared of t. And there, I've eliminated the parameter t, and now it's equal to 1. Okay, so you're just playing a game here of saying, how do I get rid of t? If there's something involving sine and cosine, force there to be an equation that says sine squared plus cosine squared, and then I can replace it with 1. Okay, so x squared plus y is equal to 1. Okay, so one more time, from the start, y was already cosine squared. I already want cosine squared. Okay, x was sine. I want to force there to be a sine squared. That's why I squared both sides. And then I decided to add these two. I add x squared and y, because then it looks like sine squared t plus cosine squared t. Then I can lose the t, and I just get 1. So x squared plus y is 1, or y equals 1 minus x squared. Okay, so I've eliminated the parameter t. Again, what's parameter? Parameter is t. It's basically t. Sometimes it's theta. It's another variable that x and y are based off of. So y equals 1 minus x squared. So I know y equals 1 minus x squared looks like this, but let's go back to the restriction. X can only be between -1 and 1. Y is between 0 and 1. So this part of the parabola doesn't really exist for this particular problem. Okay, so that's why I crossed all this out. I really only have this part over here. So the graph would just bounce back and forth just between -1 and 1 for x and between 0 and 1 for y. This part doesn't really exist. Okay, so you can see it's a little bit trickier. So that's what we have here. Okay, so one more time. I forced there to be a sine squared plus cosine squared. If I have to square something or subtract something or whatever, I do what I have to do in order to get sine squared plus cosine squared, because that way I can just lose the sine squared plus cosine squared. I can just replace that whole thing with 1. That's how I eliminate the parameter t. Parameter is just another variable. All right, now number 7 has secant and tangent. I'm going to play the same game. I need some equation that gets rid of secant and tangent. Unfortunately, there's a relation between them also. Okay, so let me show you that. Okay, x equals secant t, y equals tangent t. And yes, secant is 1 over cosine. That's what I'm writing over there. We can't see that, but you don't really need that here. So if you can't see that or you can't even read it, that's okay. But secant t is 1 over cosine t. Now, we have a relationship from trig, and if you want to put this on your formula sheet, you may. 1 plus tangent squared t equals secant squared t. Okay? All right, so I want to force there to be a 1 plus tangent squared equals secant squared. Like I have it right here. Okay, now x is secant t, y is tangent t. So tangent squared is y squared. Right? It says so right here. Y is tangent t, so y squared is tangent t squared. So I put here 1 plus y squared. And since x is equal to secant t, if I square both sides, I get x squared is secant squared t. So there it is. 1 plus y squared equals x squared. Okay. So I have the identity 1 plus tangent squared is secant squared. So I forced it. Okay. I squared this to get my secant squared. I squared that to get my tangent squared. And then I just substitute. All right, 1 plus tangent squared is secant squared. What is tangent squared? It's y squared. There it is. What is secant squared? It's x squared. All right, so what am I doing? I'm subtracting y squared on both sides. And it looks like 1 equals x squared minus y squared. And that's my hyperbola, because there's a minus sign. So just divide by 1. Put that in front, because that's the way we're used to, right? X squared over 1 minus y squared over 1 equals 1. That's a hyperbola going left and right. So there's my graph. Okay, so 1 to the left, 1 to the right, 1 up, 1 down. My box is a square. Draw the asymptotes, curve it. So there's the way it goes. Okay, now what am I doing with this table? I'm just showing what happens with increasing t as t increases. So I plug in t as 0. If t is 0, secant of 0 is 1 divided by the cosine of 0. Cosine of 0 is 1. 1 over 1 is 1. So x is 1. Tangent of 0 is 0. So I'm at the point 1, 0. So here t equals 0, or time equals 0. Then if I plug in a number like pi over 4, secant of pi over 4 is the reciprocal of cosine of pi over 4, which is radical 2 over 2. So if you flip radical 2 over 2, you get 2 over radical 2. That comes out to be radical 2. And then if I plug in pi over 4, tangent of pi over 4 is 1. Okay, so that's over here somewhere. So I know that the graph is going like this for the beginning part. But then when I get to a number like pi, so let me show you what happens with pi. Secant of pi is 1 over the cosine of pi. Cosine of pi is -1. Flip it, you still get -1. So -1. Tangent of pi, that's sine over cosine. That's still going to be 0 because the sine of pi is 0. So -1, 0. Okay, so right here, t is pi over 4. T is pi. And then at 5 pi over 4, I get -2 comma radical 1. Secant of 5 pi over 4 is the reciprocal of the cosine of 5 pi over 4, which is negative radical 2 over 2. Negative radical 2 over 2, flip it, it's negative radical 2. And the tangent of 5 pi over 4 is also 1. So that goes like this. Okay, so I have a double arrow. So both arrows are going upward. So on this branch, it's going like that. On this branch, it's going like that. So that's the way the arrows are going. Okay. Getting back to the arrows here, it just bounces back and forth forever. Okay, so as time increases, this thing just bounces back and forth like that. It never goes down to infinity or negative infinity like that. Okay. All right, so that's how number 7 goes. Okay, number 9 also has sine and cosine. X equals 3 sine t, y equals 4 cosine t. All right, so automatically, why do I put this down? Okay, cosine is between -1 and 1. If I take a number between -1 and 1 and multiply it by 3, I now have a number between -3 and 3. Likewise, y equals 2 sine t. Sine gives me a number between -1 and 1. Multiply by 2, now I have something between -2 and 2. All right, now, just like problem number 5, I know sine squared t plus cosine squared t equals 1. I force it. I force this to look like that. Now, this has a 3. Divide both sides by 3. X over 3 is cosine t. Very forceful in mathematics. I want this to just be sine divided by 2. Y over 2 is sine of t. So I want just cosine and sine. Now I want to take advantage of this, so I square both sides. So if I square this, I'll have cosine squared. If I square this, I'll be having sine squared, and then if I add them, I get 1. So notice what I did. X over 3 squared plus y over 2 squared. Okay. This thing squared plus this thing squared. That's going to be cosine squared t plus sine squared t, and there it is. Now I can just change that to 1. So this is 1. Now I can just clean that up a little. X squared over 9 plus y squared over 4 equals 1. And we recognize that as an ellipse, because there's a plus. A is 3, B is 2, and so on. Okay, so I go 3 to the left and right, 1, 2, 3, 1, 2, 3. 2 up and down, and go like that. Okay. But now, which direction are we going? That's why I have to make a little mini chart and see what happens. Okay, so I know it's part of this ellipse. Okay, so going back to here, I want to force there to be a sine squared plus cosine squared equals 1. Okay, I want a cosine first. There's a 3 in the way. I just divide out the 3. Okay, there's a 2 in the way. I just divide out the 2. Then I square them. So square that, square that. That way I'll get cosine squared plus sine squared, and that's equal to 1. Clean this up, and I get this. All right, so a little mini table. So I just went 1 period, 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so what happens when I plug in 0? 3 cosine of 0, cosine of 0 is 1. 1 times 3 is 3. How about y? Plug in 0. 2 sine of 0, that's 2 times 0, which is 0. So it starts at 3, 0. You plug in pi over 2. Cosine of pi over 2 is 0. 0 times 3 is 0. So that's 0. How about for y? Pi over 2. Sine of pi over 2 is 1. 1 times 2 is 2. 0, 2, that's over here. Okay, and you can do likewise for all the other points. If you plug in pi here and here, you're at -3, 0. If you plug in 3 pi over 2 here and here, you get 0, negative 2. You can try that out on your own. And 2 pi is easy because 2 pi gives you the same values as 0. So you're back to where you started from. Okay, so it ends up looking like this. It goes in a counterclockwise direction. So that's the way that one goes. Okay. All right, next one I want to show you doesn't have cosine or sine or any trig. It just has e's. X is e to the t. Y is e to the negative t. Okay, so how do you do that? It's actually quite simple. X is e to the t. Y equals e to the negative t. Before I start the graph, x is positive. Y is positive. E raised to anything is always positive. E raised to anything is positive. So x is greater than 0, y is greater than 0. Okay, now take a look over here. E to the negative t I can write as this, right? 1 over e to the t. But e to the t is x. It says so right here. So that's easy. Y is equal to 1 over x. Do you recall what 1 over x looks like? There's a branch like this and a branch like this. Or you can plug in some points. Okay, well, let's just reason it out. What do you get when you plug in 1? 1. If you plug in 1,000,000, you get 1 over 1,000,000, which is almost nothing. So that's going toward the x-axis as an asymptote. Not allowed to plug in 0, but I can plug in a very small number like 0.00001. This will blow up and get big. So it looks like that. And yes, there's another branch in the third quadrant. But based on what we said here and here, right? X is greater than 0, y is greater than 0. This part's not really there. So ignore the third quadrant part. We just have this. All right, and which way is it going? As t increases, you just plug in some convenient numbers. I plug in 0. If I plug in 0, I'm at 1, 1. Plug in 1. E comma e to the negative 1. Well, e is like 2.7. X is 2.7, means it's over here. Okay, so I can draw my arrows going like so. This is the direction that the particle would go as t increases. So it's going down like that. Okay. I got the table over here. Here we go. Okay, so if I plug in 0 for t, both of these are e to the 0, so 1, 1. And if I plug in 1, 1, 1, that's e comma e to the negative 1. That's 2.7 comma 0.37 roughly. That's over here somewhere, so I know it's going that way. Okay. Okay, and yeah, I want to go ahead and show you 8 just for practice. I know 8's an even number, but just to show you the theme again. X equals 3 sine t, y equals 4 cosine t, just so you can see more practice of something like that. Okay. So we're forcing there to be the equation sine squared t plus cosine squared t equals 1. I'm going to force it. So how do I force it? Okay, I don't want the 3. Divide by 3. I don't want the 4. Divide by 4. Then I square both sides. Right? X over 3 squared equals sine squared t. Y over 4 squared equals cosine squared t. Then I add them up, because when I add them up, I'll get sine squared t plus cosine squared t equals 1. There it is. So x over 3 squared plus y over 4 squared equals sine squared t plus cosine squared t, and I know that's 1. So that gives me x squared over 9 plus y squared over 16 equals 1. So b is 3, a is 4. Here's the case where you have to watch out. What I wrote before is you might automatically think, oh yeah, 3, 4, 5. Not in this case. This is not a 3, 4, 5 because a is the largest number for the ellipse. A squared equals b squared plus c squared for the ellipse. Okay, so a squared is 16, b squared is 9, subtract 9, 7 is c squared, c is radical 7, which is about 2.6. Okay, so this is not a 3, 4, 5. Anyway, okay, so left and right is 1, 2, 3, negative 3, 0, 3, 0. Up and down is 4. 1, 2, 3, 4, 1, 2, 3, 4. Here are my two vertices, 0, 4, and 0, negative 4. My foci are 0, comma, radical 7, a little bit more than 2.5, so 1, 2.5. And I go down for the other focus, 1, 2.5. So focus 2 is 0, comma, negative radical 7. All right, then which direction does it go as time increases? So I plugged in 0 and like pi over 2. Okay, so plug in 0. 3 sine of 0, that's 0. X is 0. And I got y is equal to 4. Let's see how come. If I plug in 0, 4 cosine of 0, 4 times 1, which is 1. Okay, so it starts at 0, 4. Starts way up here. And then I tried pi over 2. I get 3 comma 0. Pi over 2. The sine of pi over 2, sine of 90 degrees is 1. 1 times 3 is 3. So we're good. And then 4 cosine of pi over 2. Cosine of pi over 2 is 0. 0 times 4 is 0. So the point 3, 0. So it starts at 0, 4, goes to 3, 0. So it tells me we're going this way this time. So that's considered clockwise. So we're going clockwise in this particular case. All right. All right, then we're up to the last problems, but unfortunately the last problems have A, B, C, D. So I was going to show you a 13A and 13B, and maybe that's all I was going to do today. And then tomorrow I'll do the rest of all these that have multiple problems. Okay, so what's going on? Sketch the graph of the conic described by the parametric equation showing, if possible, where t equals 0 and the direction of increasing value of t. Okay, so these are all kind of related. X equals t, y is t squared. X is t squared, y is t. X is t squared, y is t to the fourth. X is t to the fourth, y is t squared. Okay, so they're all kind of related. So let's see how we can tackle these kind of problems. Okay. So where was 13A? X is t, y is t squared. Well, since x and t are the same, just change that t to x, you get y equals x squared. We know what that looks like. It goes like so. Now, how do I know it goes this way? You can just plug in some easy numbers. Okay, when I plug in 0, I'm at 0, 0, right? Origin. Plug in 1. 1, 1. Okay, that means it's going this way. So this particle, for instance, as time increases, goes like that. Okay. All right. B, however, reverses it. X equals t squared, y equals t. Now, let's see. Looking at the time, if I want to do C and D, okay, maybe I'll sneak in C and D also. It just makes it faster for tomorrow, I guess. Okay, I'll stop after I do C and D. I changed my mind. I was going to stop at B, but why don't I just knock off C and D too? Okay, x equals t squared, y equals t. Now this time y and t are the same. So right here, just make it a y. So x equals y squared. And we recognize that's a parabola which opens to the right. X equals y squared. Goes like that. Okay, yeah, I'll show you C and D. They're sort of related still. X equals t squared, y equals t to the fourth. And then D just reverses them. X equals t to the fourth, y equals t squared. Some of this kind of looks like A and B, but there's a little bit extra trick to it. So let me share that with you. Okay, so C, x equals t squared, y equals t to the fourth. Before we start the graph of this one, x is greater than or equal to 0. Y is greater than or equal to 0. Can you see why? We're not doing imaginary numbers, none of the I stuff, none of the complex numbers. So only for real numbers, this can't be negative. Unless, again, if you plug in I, but we're not allowed to plug in I right now. So that can't be negative, that can't be negative. So x is greater than or equal to 0, y is greater than or equal to 0. Now, based on that, y is t to the fourth, which I can write is t squared squared. Isn't t squared squared the same as t to the fourth? Okay, and you say, why do you want to write it like that? Because now I see that t squared, I can replace it with x. So it's y equals x squared. See that? So how do I get that? I force this to be t squared squared. And why do I want to do that? Because I recognize if I have something that says t squared, I can change it to just x. So here we are. T squared squared, that's t to the fourth. But now that I see the t squared, I can change it to x. So y equals x squared. So superficially, you would say, oh yeah, the parabola, y equals x squared. But not in this case, because x is greater than or equal to 0, y is greater than or equal to 0. So this part of the parabola doesn't really exist. It's not there. Okay, because I can't get x to be negative ever here. All right, so direction of increasing t, well, plug in 0, you're at the origin, 0, 0. Plug in 1, you're at 1, 1, which is like that. Okay, so we're going in this direction. And then d is similar. We can just reverse it. Yeah, x equals t to the fourth, y equals t squared. Okay, and yeah, I'll be done after this, folks. So give me a couple of minutes, I'll be done with this, then I'll let you ask questions, and if not, we're done for the day. So tomorrow I'll try to finish up the rest. There aren't that many problems left, but as you can see, there's A, B, C, D. So we're not going to be done that quickly, but I'll try to knock them off quickly. All right. So after I do D in a minute or two, that's it for today, unless you want to ask questions. So x is t to the fourth, y equals t squared. So they just reverse these. So same thing. Notice I'm writing x as t squared squared. Okay, t to the fourth is t squared squared. You say, why do you want to write it like that? Because t squared I now know is y. So I can write it as x equals y. Here's y squared. Okay, so again, at the beginning, you might say, oh yeah, x equals y squared. That's a parabola opening to the y to the right. But once again, x is greater than or equal to 0. Y is also greater than or equal to 0, right? I cannot have any negative values for y because of the squared or the fourth power. That again means first quadrant. So I don't have this branch in the fourth quadrant at all. It goes like so. And again, direction for increasing t. What do you get when you plug in 0? 0, 0. What do you get when you plug in 1? 1, 1. So again, it's going in this direction, like so. Okay. All right, so I'm done, folks. So tomorrow I was going to finish up 15, maybe 15, 17, 19, something like that. We'll see how far we can get with those. But we're done for today. Let me go ahead and check the chat if I can find it. Right here. Okay, nothing in the chat. So I'll hold it like this for a second. Okay, any questions? Otherwise, we're done for the day, folks. You can either unmute yourselves or put it in the chat. Any questions? All right, that'll do it for today, folks. Okay, so have a good day, and we'll see everybody tomorrow. Okay, bye, everybody. Bye.